All right, class, today we're on 13.3, angles and polygons. And the first thing that I would like you to do is, if you could on this page, copy down this table. Some of these you know. It's the number of sides that a polygon has and the mathematical name that we give to it. So if you want to pause the video right now to write these down, and I'll go through it in a second. So obviously a three-sided figure is a triangle, four-sided figure is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is heptagon, that's H-E-P-T-A-G-O-N, heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon. And those are all the ones that have names. All the other ones, very simply, because no one's going to remember all the names for all the sides. I mean, you could have a shape that has 300 sides. Nobody's going to remember all those names. So very simply in math, what they do is they take the number of sides that it has and just attach a hyphen with a G-O-N for gon afterwards. So an 18-sided figure in math is called an 18-gon. A 30-sided figure in math is called a 30-gon. And a 103-sided figure in math is called a 103-gon. Okay, so let's talk about the interior angles that are inside all of these polygons. Now, the one thing you need to remember as we do this is, we talked about this last week, a triangle right here. A triangle always adds to 180 degrees. Always adds to 180 degrees. So let's take a look at this shape right here. That is a quadrilateral because it has 4 sides, right? So it's a quadrilateral, it has 4 sides. And what I'm going to do is I'm going to connect one diagonal. And I just made 2 triangles, right? Everybody see that? I have 2 triangles right here and right here. So the number of sides is going to be 4. The number of triangles formed is 2. And the sum of the interior angles. Now, if each triangle makes 180, 180 plus 180 is 360 total degrees. So a quadrilateral has 360 total degrees, which you should know because, you know, when you think of a square or a rectangle, they're all 90 degrees. 90 degrees for 4 angles is 360 degrees. So let's take a look at the next shape right here. 1, 2, 3, 4, 5, 6 sides. So 6 sides, this is a hexagon. It's not a regular hexagon. Okay, we'll talk about regular in a minute, but that's a hexagon. It's got 6 sides. So what I'm going to do is I'm going to make as many triangles as possible. So I'm going to pick one vertex, doesn't matter which one, and I'm going to make all of the possible triangles. Okay, now you can't connect to the 2 vertices that are next to it because you're not going to make a triangle, but I could connect to this vertex, and this vertex, and I now made 1, 2, 3, 4 triangles. So the number of sides is 6, the number of triangles is 4. Now remember, each triangle makes 180, right? So I now have 4 triangles. So 180 times 4 is 720 degrees. So there are 720 degrees total in a hexagon. All right, so the next shape has 1, 2, 3, 4, 5, 6, 7 sides. 7 sides is a heptagon, and I'm going to do the same thing. To begin with, there are 7 sides. I'm going to pick any vertex, doesn't matter which one, and I'm going to make as many triangles as possible. Now remember, you can't connect to the 2 next to them because that will not make a triangle, but I could connect to that one, this one, this one. I now have 1, 2, 3, 4, 5 triangles. So I've made 5 triangles. Now remember, each triangle makes 180. There are 5 of them. So that's going to be 900 degrees. So there is a total of 900 degrees in a heptagon. And the last one, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides. Pick any vertex you want and make all the triangles. 1, 2. I made 1, 2, 3, 4, 5, 6. I can make 6 triangles. Looks like a clamshell. I can make 6 triangles. And the total number of degrees, 180 degrees for 6 triangles, is 1,080 total degrees. All right, so let's see if we're picking up a pattern here on the number of sides that it has and the number of triangles I can make. And as you can see, the number of sides you have, if you subtract 2, that's how many triangles you can make, right? Subtract 2, subtract 2, subtract 2, subtract 2. So let's just say I said, how many total degrees are there in a 40-gon? Well, we're not going to draw a 40-gon and try to make all the possible triangles. That's going to be a little crazy. It'll take forever to do. So if you have a 40-gon that's 40 sides, that means that you can make 38 triangles. and you're just going to do 180 times 38 to get the total number of degrees in your triangle, and 180 times 38 is going to be 6,840. So there's a total of 6,840 degrees in a 40gon. So here's the formula that you need to do. You're going to take the number of sides, we'll call that n, minus 2, and times it by 180. Very simple. Take the number of sides minus 2, times it by 180. So why don't you go ahead right now and figure out the total number of degrees in these three shapes. Pause the video. All right, let's check those answers. So a 5-sided shape, that's a pentagon. Subtract 2 to get the number of triangles is 3 triangles times 180 degrees. There is 540 total degrees in the pentagon. The 10-sided shape, which is your decagon, 10 minus 2 is 8 possible triangles times 180 is 1,440 degrees. And 52 sides, 52 minus 2 is 50. 50 times 180 is 9,000 degrees. All right, let's talk about finding the measure of one angle inside of the shape. So on the last page, we did the total number of degrees in the shape. Let's talk about how to find one angle. Now, this only works if the shape is regular. Regular means that, like, as you spin your paper around, it looks exactly the same as you spin your paper around. So if you look down here, this shape right here, if I turn my paper around, I am seeing the same shape over and over and over again. In this example, which we'll do in a few minutes, this pentagon is not regular because if I spin my paper around, it does not look the same as how it looked over here, right? Here, the pointy part is on top. If I spin it around, it doesn't look like that. But this shape, the octagon, as I spin it, it is looking exactly the same as it was when I first saw it. So that's regular. Regular means all the sides are the same length and all the angles are the same. That's what regular means. So this is what we're going to do to find one angle. You're going to do, the numerator is what we did on the last page. You're going to take the number of sides minus 2 to get the number of triangles times it by 180. That is the total number of degrees in the shape. Then you're going to divide it by the number of sides in the shape to get one angle. So let's do some practice problems. All right, in this example, we've got 1, 2, 3, 4, 5, 6, 7, 8. That is a regular octagon. Kind of looks like a stop sign, right? A not regular octagon. So what we're going to do is we're going to find the measure of one interior angle. One interior angle. So the first thing you're going to do is you're going to say 8 sides minus 2 times 180 is 6 times 180. And we did that on the last page. 6 times 180 is 1,080. So there are 1,080 total degrees. 1,080 total degrees in that shape. But I don't want the total number of degrees. I want one angle. So I'm going to now take my 1,080 and I'm going to divide it by 8 because there are 8 sides in that shape. So when I divide 1,080 by 8, you're going to get 135 degrees. So each angle in that octagon is 135 degrees. All right, this one. This one is not regular, okay? It is not regular, so we can't do this one. Okay, because it's not regular. As I spin this around, it does not look the same. Okay, the sides are not the same, and the angles are definitely not the same because this is the right angle right here. That is not 90 degrees. That is definitely not 90 degrees, so you can't do that one. But let's say you could. Let's say it was a regular regular pentagon. Let's see what would happen if it was regular. There are 5 sides. Minus 2 is 3. Times that by 180. 540 total degrees in the regular pentagon, if it was regular. Then you're going to divide that by 5 sides. And when you divide that by 5 sides, you're going to get 108 degrees. So there would be 108 degrees. Every angle would be 108 degrees in your regular pentagon. But this one's not regular, so obviously we can't do it. For your homework tonight, everything is going to be regular, so don't worry about that. And the last one, this ring-looking shape here, we've got 1, 2, 3, 4, 5, 6. We've got 7 sides. So I'm going to do 7 minus 2 is 5 times 180. That's 900. So there are 900 total degrees in that heptagon. But remember, I only want one angle now. So I'm going to take 900 degrees and I'm going to divide it by the 7 sides. And if I divide 900 by 7, this one doesn't come out to be a nice number. You're going to round this to the nearest tenth. You're going to get 128.6. 128.6 degrees. Round it to the nearest tenth.